In July 2020, IBM contributed the Sapphire codebase and related materials to the Linux Foundation's Open Mainframe project as GenevaERS. IBM's Sapphire continues to be a zip-enabled version of the GenevaERS open source project with no other functional differences. In the following, the terms Sapphire and GenevaERS are equivalent.
Hi, I'm at the Albuquerque International Airport, and doing an interview with one of my daughters, she mentioned a software product I have had experience with for almost 30 years now, 28 years, called Sapphire, Scalable Architecture for Financial Reporting. In the early days, it was called Geneva, Generalized Event Architecture System, built upon the concepts of event-based accounting or business event-based systems. The software has been used in a score of different companies over the years, usually those that have data volumes that scale beyond what most commercial software packages will be able to do, usually around financial reporting in some way, not necessarily accounting per se, and sometimes it can be sales processing, sales analysis, marketing campaigns. It's done things in dispute recovery analysis, antitrust suits, all sorts of different applications that I've used through the year. I think maybe in some of my more recent videos I'll start releasing some things more about Sapphire and its unique properties in this space, about the architecture and system and what it does. It's been an interesting system, not widely used, but it has some unique properties about solving financial systems.
On July 9, 2020, I made a presentation to the Linux Foundation's Open Mainframe project to adopt GenevaERS or Sapphire as an open mainframe project. The following is the presentation I made. I've worked with a product that originally was called GenevaERS. And when it came into IBM through the acquisition of Pricewaterhouse Consulting in 2002, was renamed to Sapphire, Scalable Architecture for Financial Reporting. IBM's gone through the process and determined that this would be useful for them if we open sourced Sapphire. Geneva is a high volume scan application. It has some affinity, some similarity, you might say, to Spark. Apache Spark is an application. It tends to have higher performance than Spark. Has always been a ZOS native tool. It generates machine code, executes it in parallel. It's been used by a score of customers over the years, currently in use for financial applications for two very large customers that require the scale of getting through hundreds of millions to even billions of rows in their daily batch cycle overnight just before they open in a business in the day to produce their financial reports. This kind of describes quickly how it was developed. We saw over the years that people would do transaction reporting against transaction files, and you'd see stacked up in the JIS queue all these programs to go read the same file. We said, listen, if we just produced all those outputs in one scan of the file, that would be much more efficient. In addition to that, we noted that quite often we had to do join processes to decode tables, small description files. So we load those into memory to do high-speed joins against those. The last thing that was done in 1993 when it was originally commercialized was it was turned into a parallel processing engine so that the history was broken up and each one of these things is run as a different thread. The real process that Sapphire is a compiler. It generates machine code. It's a domain-specific language, has a front-end application that you define what we call Sapphire views. Those are just a process, an output that needs to be produced from a scan of a file. The model that it's built upon is the good old batch program of 1,000 initiate process, 2,000 read until end of file, and 9,000 terminate. Except that Sapphire, in doing that process, each one of the views is able to see, so they become subparagraphs effectively. SAFR also has multiple exit points where times we have written code to decrypt I/O. We emulate I/O accesses to decrypt a customer-specific table and lookup routines to do specific function. It has some ETL characteristics, but it also produces reports because it does all the summarization. It originally was a report formatting tool, has kind of lost that over time as we've gone to online reporting tools, but it has rule processing, custom development, has some aspects of an RDMS in terms of the logic, but it does not store the data. The data can be stored in anything, and most of our customers use actually sequential files for storage of the data because of the volumes involved. Lines of code, C++ and high-level assembler, has Java, some SQL, so it's about 600,000 lines of code developed over 30 years. Was a new version was developed in 2000 where we went out of CICS. We still have the version 3 code, we call that. Could contribute that to open source if somebody was interested in that as well. But the current version is all of this set of code. That was COBOL and assembler. We built recently the GenevaERS website. We have a museum here of significant documents from our history talking about GenevaERS. We think that the application that we're thinking about, the IBM will still offer GenevaERS as a commercial application, but it will be zip enabled. So if you desire to have zip enabled GenevaERS, and it will be called SAFR, Scalable Architecture for Financial Reporting still, that commercial product will require a maintenance contract with IBM. We have a maintenance team that helps support our customers today. We'll be continuing that, but we have a large base of customers, ex-IBM people and customer base that we think are interested in contributing. They seem to be energetic about kicking this off. So we think we've got a good base. Coming from a services background, we've never been supported by licensed software. We always have done our development collaboratively with our customers, adding new features to the product in response to customer needs. So there's many aspects of open source that we've already been working in over the years as a tool.
I was able to spend some time with Joe Dublin reviewing, a little bit more in depth about this program or product. And what I really like about it is that it's an example of the kind of sophisticated software that lives at the higher level in the application stack for the mainframe, and that by getting it into open source, people can see, not only keep it alive, the obvious kind of open source goals, but they can see the kinds of applications that have gotten written over the past 20, 30 years, and the kind of data they deal with, and particularly building the infrastructure for financial applications that are so dominant on the mainframe. And I just think that as much as we have the basic infrastructure there and things like Zoe, people are mostly working on building DevOps and or user interface kinds of things, but we need more things in OMP that represent the valuable applications, which are the reason people didn't buy the mainframe for Zoe, so we're trying to modernize it. People bought the mainframe to run these kinds of applications.
Thank you, Joe.
Has this application been used at all in data mining? One of the problems that I've noticed from working with industry, with academia, because we do a lot of data mining and AI and learning machines, but one of the problems is formatting all the data to get ready to feed into the learning machines and things. Would this application have that capability?
Yes, it could play a couple of different roles in that space. Let me say what it does not play into right now. The only sort of arithmetic operation, it only does arithmetic operations today, and it doesn't have an extensive library of machine learning kind of modules and sophisticated mathematical models that it can call upon to do its work. Also, let me say what it doesn't do as well. SAFR's highest benefit comes when it's resolving hundreds of queries against a very large data set. And that hundreds of queries often requires that you're waiting at a specific point in time to resolve those queries. So if you start to get more to an end user query sort of tool, the performance benefits of SAFR drop away. In some respect, you still get very efficient pass of the data, but you don't get the most efficient pass of SAFR. But having said that, it has all the capabilities of doing transformations of all kinds of data types to get to clean data. And the data sets that we create, these very large data sets for our customers, are very clean data in very structured ways that lead them and lend them their ability to use these kinds of things in machine learning sorts of processes subsequent to SAFR. It could be enhanced to add more of those kind of capabilities directly into the tool as well.
Yeah, I'd like to see it do the pre-processing, you know, for cleaning the data for the data machine learning, because you don't want, you want to do too much, you know, you don't want to do everything but eat, you know, kind of thing. So I see it as a step one to process the data and then allow the learning machine algorithms to do their job.
It could.
Thank you.
Kip, you mentioned Spark and comparisons at the beginning of this. Why not simply try to incorporate the best parts of Geneva into Spark? I mean, if there are certain things that it does better, and to make Spark more readily available on z/OS?
I've done work over the last 3 years, and our customers have been interested in modernizing for quite a while now. And I've done quite a bit of prototyping and work with Spark, both some on Z and off of Z as well. I just recently, as part of our open source work the last month, we've kind of come up with this architectural direction. And we could see some intersections here between Spark and what Geneva does today. I might use the term SAFR, just excuse me, I'm still getting used to designating my names correctly if I ever use that incorrectly. The thing that's unique about GenevaERS, though, is that Apache Spark is an analytical application. Geneva does a master file update. Apache Spark isn't really written for large output processes. And that master file update writing process is something that makes our customers have noted, hey, if I put in my backup capabilities in Geneva at the same time it's doing the daily pass for all of the queries, it can write the on-site and the off-site backups at the same time, and I get more efficiency out of it. All of that kind of work, they're using Geneva's one-pass process to do those updates and backups at the same time. I wouldn't think that you would use Apache Spark and add into it your backup capabilities as well, because it's not really written for output write processes. It's meant for aggregation and map reduce to get you to one answer. There's also some things called common key buffering that is a unique kind of processing mechanism whereby we do large table joins against millions of rows records. It's a hierarchy process of match merge that I think gives SAFR, Geneva, the highest performance and most utilization. It's not something that's in Apache Spark. It could be added to Apache Spark. So there's some interoperability that we're looking for driving in the open source world. Our customers do have things that they'd like to run in Apache Spark at times, which would be more effective for them on a different platform. They'd like to use SAFR Workbench metadata for doing those processes. We'd also like to be able to take in and open up this new Java code way of getting processes into SAFR so that we could actually become an Apache Spark execution engine for the set of functions that SAFR can do, Geneva can do on z/OS, and we think we'll have higher performance. We know we'll have higher performance. Our code base, a customer just converted tried to convert a SAFR process to Apache Spark. It went from 40 minutes with a lot of tuning, some very high engineers involved, to 6 hours of processing time. Geneva's scale is still unmatched. It's much beyond what Apache Spark does.
I know, but again, it's still the question of making Apache Spark more accessible to z/OS clients.
And we could have some aspects of that. We can, in the open source world, we could work on that. We think the faster way to do that is to put out our code base, have the mechanisms and the things that we do within Geneva understood more broadly, and be adopted, utilized when effective, or changed if not effective, and improved in other ways is probably the fastest way for us to get there.
I'd like to comment on that. I think if the open source were out there, not only could the existing goodness be maintained, but if someone wanted to build a highly scalable parallel RDD, a Spark RDD populator from it, they could do so. And it would probably be hard if it weren't open sourced to do that, so that, one of the back ends or, places to which Geneva could flow forward, if it could flow forward efficiently without having to, serialize the data out to data files again, but build that sort of custom populator the way sophisticated SQL interfaces work in, Spark to get all that data in there in parallel would really be the key. And also, I thought Apache Spark, in quotes, worked perfectly on mainframe, in that the mainframe Java is very good and it just works.
Yeah, but the issue is instruction path length. We are Sapphire Geneva tends to be 50% to 60%, even 70% faster than COBOL. So our instruction path lengths are incredibly short, and it's been tuned over 30 years. We go to machine code the processes that we've developed. So if you're going to a JVM, you're going to be executing more. You're going to have a longer instruction path length just because of the JVM, even if it's very efficient. You'll have a difficult time beating the Sapphire performance. It's been proven by our customers. They have looked for alternatives for a number of instances, a number of times, and do not find anything that has the scale that the Geneva has.
Right. But if the downstream processing is more complex than what Sapphire can handle, it's good to get that data directly shunted efficiently into a Spark cluster.
Exactly. That is right. And on just a discussion today with Joel, the IZOTA solution on IBM on Z uses MDS as its feeder. Well, Geneva could use MDS as its feeder. Geneva doesn't have a lot of ETL. It has an ETL characteristic, but it doesn't have a lot of connectors to different kinds of data types. It doesn't read IMS natively. It reads VSAM, DB2, and sequential files. But it could use MDS to get to greater sets of data on Z as well. So there's integration points here, multiple ways that this could go.
Is there a large list of APIs that you have with this product? Or is that something that you would do with in open source?
Well, we have, in terms of APIs, we have API points and multiple exit points in Sapphire today, like IO, input and output API points, lookup API points. So, but those have to be coded to the Sapphire specification, the linkage requirements of Sapphire. Geneva is the primary address space. It wants to initialize the primary address space because it's a parallel processing engine. So there's some limitations in that way. And also, again, it wants to resolve all the passes in a single pass of the file. But we do have some thoughts around if we were to open up a SQL interface and make Geneva a started task that simply scanned the files when it had queries, that it could then become a simplified SQL resolution engine that would give you greater interfaces to the reporting applications that are SQL based. So those are all things that would be driven by customer demand and contributions to the project.
Do you already have people, like customers, partners that are aware of this proposal and are eagerly awaiting the opportunity to extend this in one way or another?
We have not, but as a consulting organization, like I said, we don't have a large sales force and never have had a sales force pushing Sapphire Geneva. So we don't have a list of customers lined up today. Our 2 customers that we have are both very supportive of this and excited about the open source prospects of it. We do have a community of existing GenevaERS people in Dispersia, not in IBM, that are in other organizations now that are interested, and we already have some contributions from them that have started up in the last month. But we don't have a long list of customers right now that are looking for this. This discussion we're having today would be probably the longest discussion we've had about GenevaERS with a knowledgeable set of people. Anyone that you would be interested in referring, we'd love to hear from them, get their feedback about where we go and how we do things. There's some related things as well, just so you're aware. I'm running another open source thought leadership thing called Share a Ledger, which is kind of branching. Sapphire could be programmed to do a lot of different applications, but this is more about specifically around ledgers and how we get greater efficiency in our ledgers, not just on Z, but any kind of ledger. ERP systems have ledgers embedded at the bottom of them. So that's a related project that would be supporting this. I also run financialsystemseducation.com, which has a list of resources around ledgers and financial systems and Z technology and other kinds of things. So these are all supportive of what we're trying to do here, would be included as part of the project.
Okay. So I have to leave in a few minutes. I just wanted to throw this opinion out there to see what other people think. But my thoughts here is that this is kind of a first of its kind opportunity for mainframe open source, in that, to my knowledge, there's nothing that's really dealing with transactional performance in ZOS open source thus far. And so it's hard to see where we'll go from this point, but I think it's very interesting to try it out. My main concern is just due to it being the first of its kind, I don't know where the maintainers will come from, but I would say that we don't really know until we try, so it's worth a shot.
Can I just suggest to you, we do have a maintenance team inside of IBM that's supported by our 2 maintenance customers, and they will be supporting in some measure the existing code base. Certainly open source adds a level of work effort to go beyond what we're doing today for our customers, so we don't have unlimited capacity, but there is a multi-year maintenance contracts in place that does continue to support the code base. It's falling off the edge at this point.
Cool. Hi, this is Phil Kelly. I think from my point of view, this is, well, I have very little input on anything that happens on a ZOS system anywhere. From a simple open source project, look, this is exactly where we should be going. I mean, this is an active tool being used, and we want to expand its presence and open its source. So, and engage other people possibly into maintaining and expanding on it. So I think from my point of view, it's definitely we should vote and bring it to the table as an open mainframe open source project.
All right, I hear that as a bring to the table for a vote here. Do I hear? I'll take yours as a motion to approve there, Phil. Do I have someone coming behind on a second?
I'll second.
Awesome. So voting members, you know who you are. All in favor of taking this in? Aye.
Aye.
Aye. Aye.
Aye.
Any oppose or abstain? Congratulations, Kip. You're lucky number 13 of projects in the Open Mainframe Project. Welcome.
13. That's lucky number 13. Thank you. That's a great spot to be in.
Excellent, excellent.
Okay.
We'll follow. We'll connect sometime here in the next couple days with next steps.
Thank you very much.